Okay, in 1 second. Okay, let's go to the tasks. I hope the Explorer works. Let's just start. You're given A, B, C, D, print to a line. And contains resulting, and the second line should contain regardless of the input. Okay, whatever. Okay, Visual Studio Code is gonna make some problems. Should be fine. Okay, this will solve. Generate 10 strings as follows. Let SI be okay. Next, choose 4 integers satisfying these conditions. Then for each pair, replace that with this. You're given generated as above. Find ABC, which the class it chose. It can be proven that uniquely exist under the. Okay, this is fine. Let's solve them. Okay, so we are given 4 integers and we want to print on one line. We want to print this A plus B times C minus D. There's no overflow, and on the other line I want to print the name. This is stupidly simple, but it's just okay. Rectangle detection. This will be simply just finding the bounding box of the rectangle. So A is the minimum, so if V of I of j is equal to this, A is the minimum of A and I, right? Yes. B is the maximum of B and I, C is the minimum of C and J, and D is the maximum of D and J. Here we have to define them. So wait, the B is minimum, so this, and then C, A, C, D. Passes the samples, should be correct. Okay, let's go for C. Passes, accepted. You're given a non-negative integer and print all non-negative integers x that satisfy the following condition in ascending order. Set of the digital position containing 1 in the binary representation of x is a subset of the set of the digital position containing 1 in the binary representation of n. That is okay, so you're given some x 2 to the 60 power. What is that? 2 to the 60 is too much in the binary representation. At most 15 digits contain 1. Okay, we already have that. So okay, so we want to just to count from like the binary, but you want to start at 0 and then so what is the best, how the best to do that? So take how many bit count. So in bit count is built in pod count of n. But this is unsigned integer. I'll do this. Uh, 61. If n and 1 LLI, then bits plus. Then we know that we're gonna count from 0 to 1 all to the bits, right? Now we only need to modify the number to fit to the n digits. So when we get the bits, we say on what what is the best way to implement this? Like this. Push back high. And then we want to say that, okay, we have the ith bit. And we count so LL current answer is 0 for each in bits.size if I and 1 LL of J, then the current answer should be ORed with bits at one LL at bits at J. If that is correct. Okay. And gets accepted. You have infinite hexagon grid. Initially all squares are white. Let's just see the standings maybe. Okay. We're first. We have an infinite hexagon grid, all squares right, 0, 1. A hexagon is represented by a hexagon is adjacent to the following squares. Just painted n squares, black, find the number of connected components formed by the black squares. 2 black squares belong to the same yes. Okay, so n squares are painted like this. Okay. So from each square we can so there are various ways of doing this. The best way to do this should be probably some kind of BFS or DFS on the squares. Yeah. Okay. So probably BFS will be simpler. So we can even iterate over all of the squares twice. Okay. Okay, so let's call this brute force way. Squares or the pentagons, whatever. The hexagons. Doesn't matter. I think you can see it. So like this. Just a simple BFS. BFS empty. BFS pop. So okay, if I could continue, yes, suppose answer BFS push I true. Now we want this adjacency list. TX 6. Okay, -1, -1, 0, 0, 1, 1, -1, 1, 0, -1, 1, 0, 1. Okay. 1, 4, and just a simple BFS, and then iterate over the squares. If there exists, then we BFS that push J if listed that J is not, BFS that push J is true, then we want to, are they distinct? They are distinct, want to break. Okay, and then see our answer. Should work for, because end goes only to, it's on time limit at least, I think. It should be quite fast, yeah. Okay. So this one, let's go to E.